Hello, I'm MC Toon, and it's Tuesday, and it's night, and it's 9 o'clock p.m., a little later than usual, but I've got a debate. This is a debate with DrainoPitt1. No idea what that means. He's on TikTok, and he was making some noise complaining about some of the videos I did. So I said, hey, well, let's go. And he said, okay. So he is live on TikTok, or he was live, and now he's no longer live. But I am ready for when he is live. I don't know. Like, he was just live and then stopped. I was listening, and I messaged him. I said, hey, I'm almost there. Because this was the time was when we were going to do it, was 9 o'clock.
Like,
so.
no, it isn't. Yeah. And then I
Hold
Googled
on.
monotreme because
Here, there you go. All right, that was somebody else's live stream. So I don't know where DrainoPitt1 went. So I'm going to, and I know I'm sure he'll be there. He was in his car. So, all right, all this. TikTok automatically plays everything, so I'm hearing it. I'm trying to focus. All right, well, anyway, I'll get him. He says he's ready. He wasn't upset yet. Give him a minute before he think he rage quits. Let's see. I can show you. I have a whole TikTok like thing where you can see what I see. Do you want to see my screen on TikTok? All right, here it is. There you go. There's my TikTok. So you can, here's my profile. There you go. That's what it looks like if you've never been on TikTok. All right. He says I was rebooting my router. I installed a new Wi-Fi access point so that my phone's right there. So my phone has a fast network connection. So I bought just for today, a faster, a dedicated Wi-Fi access point just for this office. Because the other access point is that way through some dirt. So directly underneath me is dirt. The rest of the house has basement if you go far enough that way. So. Real Cygnus, yes, I think you've correctly identified some traits. So, anyway, he's all right, ready. I had said let's do it on Zoom, and he's like, I only do it on my platform. TikTok, I gotta tell you, TikTok's not your platform, in case you didn't know. Liz K. Yes, TikTok is a cesspit. The problem with TikTok is that there's short attention span. And what are flirfs? Short attention span. So you guys, you don't need to go to TikTok. I will go fish them out and bring them to you and then crush them for you in front of you for your entertainment. That's what I do. Is that a picture of Trump he has in his logo? He actually has that logo. I did a reverse image search to find it. I have no idea what his logo is, what he intends it to be. But so the one that he had on TikTok was tiny. But yeah, maybe it's Trump. I don't know. I just got a higher resolution version of it. So I don't know. He was just saying he didn't like Trump. So String News 1 for $5 says even MC Toon's Wi-Fi disappears bottom up because of the curvature of the Earth. For sure. Okay, now he has shared his live. So there we go. There it is. So I don't know if you can. There you go. You should be able to hear even. So there's his background. So I don't know. Can you hear me? DrainoPitt1. I think he went out. I don't know. So I you're actually seeing my phone screen, and I have it cropped so you don't see too much. All right, DrainoPit. DrainoPit, are you there?
Hello.
All right, here we go. There we go. Do you hear me?
I got you this time.
All right. Well, good. And I am simultaneously streaming to YouTube.
Cool. Yeah, I was having technical difficulties with my wife's Apple phone. For some reason, when I sit out of my truck with my Android, I have no problem picking up the Wi-Fi. Her Apple, for some reason, just doesn't like reaching that distance. I don't care.
Well, it's still cutting out.
Still cutting out a little bit.
It's not great. Yeah.
You're I can hear you crystal clear though.
You're in a car.
Yeah. Outside.
I'm in my office, as you can see, because of the way it is.
You got a fan or something running in the background?
Oh, I do. I can turn that off.
Yeah.
There we go.
That's why I say I hear you crystal clear.
There we go. All right. I have headphones on. That helps me. You see, earbuds actually.
Yeah, I'm trying to get. I was in the process. I had my headphones latched up to her phone, so I'm in the process now trying to get them back myself.
All right.
I'm not Apple savvy by any. I'm an Android guy.
Okay. So, all right. Well, you got worked up by some of the videos I put on TikTok there that were challenging the flat earthers that think that the sun is literally inside the clouds. But it seems that you don't have that position, and you were taken. Maybe I didn't understand. What was your?
Right. Yeah, you were right. I wouldn't. Planes or whatever where the sun appears to be in the clouds, but I don't prescribe to that belief. So I think that was where you kind of had got me, because you were making it seem like all of us believe that, and I just
Oh no, I know.
Come out and let you know
I know that
not all of us believe that.
There's a lot of disagreement. Some think there's a dome, some think there isn't, some think that there's an edge and you fall off, some think that it goes forever, some think that there's an ice wall, some don't. I don't know. And you're paused. He's paused. I don't know. And you can read their let's see. I can invite. All right. So I can arrange this so you can see a little more, but I don't know what happened. He just went away. Oh, there you go.
I got you.
What happened? You're
I'm just having technical difficulties over here. I'm straight now, I think. I got my headphones connected and I can hear you good. You hear me good?
I do.
All right, let's rock.
All right. So so you don't think that the sun is literally in the clouds. So where is the sun?
No. I mean, I think we can, see from plane footage that the sun is obviously above the clouds.
Okay.
I would say I personally think if you have like a dome theory, flat earth theory, I would say, in my opinion, that the sun is encased in the dome, not like inside, say if you take a glass bowl and you flip it upside down, not just the sun inside of the bowl, but like inside the actual glass itself. So it would be locked in that glass dome, so to speak, is the way I think it works, in my personal opinion.
So it's just kind of a guess?
Oh yeah, it's definitely a guess.
Okay.
I mean, have you ever been up into space?
You don't need to go to space to figure out things about it. It's not how it works.
So how would you figure out from the ground? How would you personally figure out what the distance is to the sun?
I would triangulate. Because we know
Okay.
we
How
know
does
that
that
there
work?
we know that there is a subsolar point. At every moment of the day, there is a place on Earth that's directly below the sun. If you look straight up, you see the sun, and there's no shadow anywhere for like a vertical pole or anything at that point. And the specific location where that is known pretty well. And timeanddate.com, in fact, will tell you exactly where it's going to be on any particular day. We know it's between the Tropic of Cancer and the Tropic of Capricorn. On the June solstice, it goes around the Tropic of Cancer. And on the December solstice, it goes around the Tropic of Capricorn. These are easy things to confirm. You just have somebody go to the place where the sun is going to be directly above on that day and ask them. And people do that all the time. For centuries, it's been celebrated, especially on the equator, like in Ecuador. They've had all sorts of parties and things for a long time on the day of the equinox, when the sun there, because Ecuador is on the equator, where the sun goes straight overhead that day. So we know where it is. So if you know where it is, and if you know where you are on Earth, you know the distance across the surface of the Earth from where you are to where the subsolar point is. So if the hypothesis of the Earth being flat is what you're going to test, then you know the distance between you and that point.
Okay, so explain to me what a subsolar point is before we get too far.
I just did. It's the point on the surface of the Earth, directly below the sun.
Mm-hmm.
If you look up,
Okay.
straight up, you see the sun.
So you only need one person to triangulate the distance to the sun at the subsolar point. Just one observer.
You don't need somebody at the subsolar point. The location of the subsolar point is well known. It's been well known for centuries. Timeanddate.com will tell you where the subsolar point is for any day that you want.
Yeah. But you still need somebody there to take the measurement, right?
No, you can measure from where you are. You know where the subsolar point is, and you know where
you need two
are.
People.
One person.
Right. So I would check my angle here, and then I would correlate with somebody at the subsolar point with their angle.
If you didn't think that the centuries of subsolar point knowledge is correct, then yeah, you could send somebody to that spot to confirm that timeanddate.com, for example, is right.
So what's so special about the subsolar point that you have to have one person there to figure and triangulate the distance to the sun accurately?
Again, I'll say it again. You don't need to have somebody there. The location of the subsolar point is well known.
So technically I can have me here in Virginia, say, and then have somebody in, say, North Carolina, 50 miles away, 100 miles away, or whatever, and do the same triangulation, and the math should work.
Well, the subsolar point is never North Carolina.
But so you said you didn't need anybody at the subsolar point.
That's
wasn't
right.
that
one
wasn't
one person. One person.
Must.
One person is all you need, not two, just one. So I know where I am. I'm in the Minneapolis-St. Paul area, very close to 45 degrees north latitude.
You're using okay, I get you. You're using the subsolar point as your right leg of the triangle because you know it's 90 degrees from there.
Yes, that's where the 90-degree angle is. So
okay. So again, that's why I would say, if you're just creating right angles to measure the distance to the sun, do you have to have to have somebody specifically at the solar point?
Nope, you don't need anybody there because for centuries we've known exactly where that is. But if you question that knowledge, you certainly could send somebody there.
Right. Yeah. So it's basically just triangulation. As you say, it would be a right triangle. It would have to be a right triangle. You couldn't measure it with, say, a 89-degree triangle.
But you could if you knew where that point was. You can solve any triangle. But it's much easier to do a 90 because you know where
it's more
where that angle is. You know the subsolar point. There's no question. Well, where's the sub 98 or 89 degree point? That's harder to say.
Mm-hmm. And so I had gotten into a discussion with Globe Man about this. We were talking about how, like, you know, you're at the beach and you see the rays coming directly down and touching the water. And then you may have another spot way over here, same thing, but at a steeper angle, you know. Well, if you can figure that you have a 90 there on the water going straight up, other than, you know, just in your view straight in front of you, it appears to go straight, you know, on a 90, then you could take your other angles, and if you actually knew the distances between the two, you could triangulate the same way, could you not?
Are you talking about the pictures that I posted where it looks like the angles of the rays are coming down?
So you don't think the light ray is actually coming down from the sun touching the water?
I think it is, yes.
Okay, so then we can technically trace that light ray back to the sun and create, if you had a picture with two angles, you know, if it formed you a nice perfect right angle, so to speak, you could triangulate it from right there.
And
if you're
there's
standing
only
at the subsolar point by yourself.
Yeah, and there's only one subsolar point at any moment. And it's between the Tropic of Cancer and the Tropic of Capricorn all the time. It's never outside of them. Right?
So all right.
So
if I'm not standing at the subsolar point and I observe the, you know, sun away from me at an angle like this, I can still create that right angle either way.
Yeah. So
you don't have to be there.
Exactly. So so you are where you are in America, right? Whatever your location is, and that subsolar point, and then you can solve this triangle, and then you know how high for flat Earth, how high the sun must be. Right. This is a pretty easy calculation to do. And I've done this.
All right. So what I'm thinking is,
I've done this on all of
I'm thinking is, all right, if you had 2 observers or 3 would be better. And all of you went, you know, I stand here, you got one guy, he goes over 50 yards or whatever, 100 yards, 200 miles, and then the next guy takes an exact right angle from him. So you have a right angle created on the ground through the observers. Now, if you're looking up at the sun, you still have that right angle on the ground. You shouldn't have to be at the subsolar point because you're still creating a right angle. The right angle is there. It's just not, you know, sitting like a plane on a plane like that.
Why are you
get
doing
what I'm saying?
Why are you doing 2 people?
So that you wouldn't have to have the subsolar point as a reference. You are making a right angle on the ground between your observers.
But there's no right angle on the ground. Then the problem is there's no right angle on the ground.
Yes, there is between 3 observers. If you do your calculations correct and y'all are 90 degrees from each other, that creates a angle on the ground, right? So you have your right angle there is what I'm saying.
Let me get this straight. You want 3 people standing on the surface of.
So what I'm trying to get at is let me finish this. I just want the subsolar point to have the 90 to technically. You can get a 90 anywhere on Earth. The 90 doesn't have to be directly below the subsolar point.
But straight up from that person will not be the sun. You need the subsolar point to get a 90 to the sun.
You're creating the 90 at your feet with the multiple observers.
Okay, so
the 90 is on the ground.
So to be clear, you get 3 observers on your hypothesized flat Earth, and then you have those 3 people create a triangle with 90 degrees between each of them.
Right, so they create an equilateral triangle. They're the observers.
With 90 degrees at each corner of the equilateral triangle? That's on the flat Earth? Okay. Do you not see a problem with that?
Do you understand where I'm getting at?
Oh,
You do not understand that you don't have to be under the subsolar point to create a 90-degree angle.
So you've made a 90-90-90 triangle on a flat surface.
Right, on the ground. Your observers are 3 90s, all 3 on different sides of the sun, one looking right at the sun, one looking left at it. You're still getting the 90. The subsolar point is just basically your way of saying you have to be here to create the measurement to get our measurement for your distance to the sun.
I'm just trying to draw this out just to be clear here, so that we all understand this. This is what you're proposing.
Right. How does that work on a ball? Don't you guys say that you can do two right angle turns on a ball and it makes a equilateral triangle?
Yeah, I mean this is what you're
right angles?
this is what you're proposing to do on flat Earth.
Right.
I don't know how
it works on a ball, does it not?
Yeah, you can do this
Can
on
you
a
not
ball.
make a right-
Yeah. In fact,
Yeah.
I did it. It's on my. I have the flight charts right there on the wall behind me. I did it with real flight charts.
So you did it on a flat map?
No,
So
I
you
did
did
it
it on a flat map.
No, I did it on the Lambert conformal conic projection map, and when you put them together, it forms a sphere. And that's what I did. I actually put it on.
So we gotta tape the flat maps together to make a sphere.
That's what happened. Yeah, because they're Lambert conformal conic projections. When I connected those three together, and I put them on a sphere that I made out of PVC pipe. It's the second and third videos on my channel.
So you're standing on a sphere now. If you go out in your yard, can you go walk from your back door, make a right angle, then walk 20 or 30 yards, make another right angle, and come back to your door?
No, each leg has.
How it works, because you're still on a sphere, right?
Each leg must be 10,000 kilometers long.
Why does it have to be a certain distance long?
Because that's the trigonometry of it.
Of a ball, right? It's the only way that equation works is on a ball, but you guys can't recreate that in reality.
Oh, we can.
It just has to be.
You actually can.
10,000 kilometers on a ball.
You could fly those. Yeah, that's
But
the
you're
reason
using
why
a flat
it's
map, though, buddy.
But it's not a flat map. It's a Lambert conformal conic projection map,
It is a flat map.
When you put them together, it forms a sphere. That's what I did. It's on my channel. You can watch the video yourself.
So
you can print out your own charts.
Striking together composite images like NASA. We're striking together composite images.
Yeah,
like
they're
NASA.
Since they're all taken. Since the source is from the same globe, and it's projected onto a Lambert conformal conic projection, when you put them together, they form a globe.
Okay.
So, back to this. This is what you want to. Just to be clear. This is what you want to do on your proposed flat Earth to measure the angle to the sun. You want to have 3 people involved, and they're 90 degrees on an equilateral triangle on flat Earth. Okay.
Right.
How far do these legs need to be on flat Earth for that to make?
Well, you
90,
don't have a sun
90,
up there.
90.
First of all,
Yeah,
where's your sun at?
I'm asking you. This is your.
Put the
this
sun
is
up
your
in the sky. Put a sun up in the sky.
Right here. Right directly above.
Now up in the sky.
Up here somewhere, right?
So you got a sky above in the middle. That'll work. So from there, you can, if you know the distance halfway between the bottom line, right? Yep, halfway.
Yeah.
Your top observer is going to create, if he's looking at the halfway point, is he not creating a right angle when he's looking up towards the sun?
No, he doesn't look. He doesn't see a 90 right angle when he looks to the sun because he's not directly below the sun. He's not at the subsolar point.
Okay, but the ground is it's still a 90 at the subsolar point.
Yeah, it's always a 90 at the subsolar
We get that.
point.
Yeah.
Yeah, or a straight vertical. Yeah.
So where's the assumption in your math? Is what I'm saying. There's an assumption somewhere in
this
that
is
math.
This is your measurement, not mine.
Yeah,
This is how you want to measure the elevation of the sun.
I was trying to explain, right? A mental experiment for you to realize how that you can create a 90 anywhere. 90 can be created anywhere.
But I don't know where the 90 is because only the subsolar point's going to have the 90.
Okay.
Because this person here's that their angle to the sun is going to be not 90. Right? Or if you're talking zenith angle, zenith is 0 when you're directly below it.
Right. So if I'm in Virginia and I'm looking up at a sun during noontime or around noon and it's 89 degrees, you've already said that I can use 89 degrees to create the triangulation measurement.
You
Is
could.
it
Now
not?
it would never be 98 degrees.
Okay.
It's going to be quite a bit lower than that, but yes, you could use the
I
angle.
said 89.
If 89, 90, it's going to be in
Right.
it's going to be less than that based on your
Regardless,
latitude.
I think we're going off on a moot
right.
point here for both
So-
of us.
so it's
because
easier with just
you really,
one
like
person.
you say,
Just one.
it doesn't have to have a 90 to be measured. We've already agreed on that.
Yeah. But I don't know. But how you're going to do it? Your proposal didn't quite make sense. I don't know how that math's going to work. But this math is pretty easy, actually.
So you've already said we don't have to have the 90 to measure it.
You don't. But if you
It
don't
doesn't-
have
you said
if you
it doesn't
don't have
to be
the 90,
so then how am I going to do it by myself if I'm standing in Virginia,
exactly,
looking at a sun at noontime at 89 degrees in my sky? I can still measure it, right? You've already said that it can be done without a 90.
Like I said, it wouldn't be 89 because you're not that far south.
All right, so let's get off of this point because I don't think we're going anywhere with it.
No,
because we can agree.
I think
it doesn't have to be a 90 to measure.
You can invent whatever way you want to measure it, but this is an easy way. The one that you're talking about is more complicated and requires more people and more math. This is pretty easy to do. If you know this distance here, and you know that you have a 90 and you measure this angle, you have angle, side, angle, you can solve that triangle, right?
I understand. Yeah, I understand the right angle one. So now back to my point with the three observers. If they're all observing an 89-degree angle, it doesn't matter if they're at the subsolar point or not, does it?
If they're at an 89-degree angle, they're going to be just 110 kilometers from the
Pretty
subsolar
close.
point.
I mean, all right. So I mean, whatever 75, your claim is you can still measure it without a 90. You don't have to have the 90.
You could, yeah, if you wanted
your
to
math
have.
can still be done.
If you wanted to orient people all around the place and then have them measure those angles, you could.
Right.
But like I said, the trigonometry is going to be a little more complicated. And so if the trigonometry for this one has you scratching your head like, how would I solve that triangle? Then this other one's going to be a lot harder.
No, I'm not scratching my head how to solve a right triangle. I know how to solve the Pythagorean theorem.
But yeah, that's
all right,
not.
So let's
that's
just
not,
move on because
no,
I think,
hold on. I just want to be clear.
On a point here that we're spinning wheels in the mud here because you've already admitted that it doesn't have to be a 90.
I'm saying there's lots of ways to calculate.
We can measure it.
So
right.
let's do this. Let's
say
I've
looked at several of them.
Let's say it's 45 degrees right there. Now the triangle's not showing 45, but let's say it's 45 degrees. I've personally measured it on the equinoxes, both equinoxes, to be within just a very small amount of 45 degrees from where I live. And then we know this distance because I know how far I am from the equator. Right? If I'm at 45 degrees north latitude, how far am I from the equator?
I'm sorry, I wasn't paying any attention.
If I'm at 45 degrees,
I was looking at the comment.
If I'm at 45 degrees north latitude, how far am I from the equator?
Well, what is the equator at?
It's at 0 these days.
I forget.
Yeah, we keep
It's
it
at 0, and then
0,
everything goes up from opposite of it. Yeah.
Yeah.
So you're 45 degrees away.
Yes. So if I'm 45 degrees away from the equator, how many miles, kilometers, nautical miles am I from it?
You're asking me something that I haven't studied in 15 or 20 years, man.
Okay. Well, I'll just tell you this. 1 degree latitude, ooh, my marker's getting a little dry, equals 60 nautical miles, or 69, no joking, miles, or 111 kilometers. All right? Right there. So all we need to do is multiply, right? 1 times 69, if we want to do it in imperial units, we get 3,105. All right, 3,105 miles between myself and the equator, and I personally measured 45 degrees. Well, that's a 90 and 45 and 45 triangle, so we don't even need to do anything to know that this distance here is also 3,105. Ooh, bad. Hold on, I gotta write it down.
So, in other words, you're doing your math on a flat leg triangle
Yeah,
that
this
should
is
be accounting for the bottom leg should be a curve, shouldn't
no.
it?
This is hypothesizing that the Earth is flat. This is testing
Oh, so
to
you're
see if the Earth is
hypothesizing.
flat.
I thought we were still talking about how to measure the distance with the right angles.
Yes, for flat Earth. Because I asked you for
Wait a
flat
minute,
Earth how
I thought
high
this
the
was
sun
your
was.
model.
No, this conversation began with me asking you how high is the sun in your flat Earth, and you said you thought that maybe it was encased in the dome. Well, if it's encased in the dome, then the dome on the day of the equinox must be measured from Minnesota must be 3,105 miles in elevation. That's right. This is covered in typically 10th or 11th grade. We don't use it, so we get bad at it. But this is not hard to do.
So
right?
I'm gonna tell you one thing wrong with that though. You're assuming the size of the sun and the brightness.
Where did I put the size or the brightness into this formula?
Because you need to know the size of the brightness to know if you are reaching the actual sun itself for your measurement.
How's that? Where in this formula that I used did I plug in the
Did
size
you use a
or the
solar
brightness?
filter when you measured it?
No.
Did you use a solar filter when you measured it?
But you don't need to measure the angle to the sun. You don't need a solar filter. You can do it by having something cast a shadow and measure the length of the shadow. Do the similar trigonometry. If you want, you can use a theodolite.
So
you could use
the
a
length
sextant.
of a shadow will tell you how. So the length of a shadow of a stick, 2 foot long stick, will tell you how far away something is.
No, it tells you the angle. It tells you this 45 degree angle.
So the angle tells you. So the angle. How does the angle tell you?
So when you measure the length of the stick and the length of the shadow, you can solve the triangle to get the angle that the sun is.
Right.
Now that's one of many ways to get the angle to the sun, the angular elevation of the sun. You could use your phone. You can install on your phone an app on an iPhone. It's called the Theodolite app. You can measure angles with it, vertical and horizontal angles with it. You could use a real theodolite. You could use a sextant to do it if you were near water or had a bubble sextant. There's any number of ways that you could measure the angle of the sun. They all will give you the same answer. For Minnesota, on the equinoxes,
what I'm saying is,
it's 45 degrees, middle of the day.
What I'm saying is, you have to assume the size. You have to know the size of the sun because.
Where did I put the size of the sun?
I'm sitting here looking at. All right, so just listen. You got the moon in the sky. I'm going to use your triangulation method to measure the moon. Now a plane flies by in between the moon, or let's say a helicopter for intensive person, because the helicopter is going to stop in between you and the moon and sit in front of the moon. So now you're telling me that same right angle and all we just measured with is going to measure the same distance to the plane and the moon because they're both at the same degree.
No,
from
because
the right angle, from
plane,
the ground
the
perspective.
plane has a different subsolar point. The subplanar point.
What if the
moon.
plane is at 90 degrees? The plane is directly under the moon at 90 degrees.
Yeah.
We were talking about the moon too.
Yeah. If
the moon still have subsolar point like the.
It has a sublunar point, but yeah, it's the same idea.
Okay. Is that 90 degrees too?
The same trigonometry happens. The same geometry. Yeah.
That's what the sub point just notates is the 90 degree directly above it. I got you. So technically, like I say, if we're standing there doing your trigonometry at, the plane is at 90 degrees, just like the sun is, we're observing it. Now you're measuring, you're going to tell me the plane is going to be the same measurement as the sun you're observing because it's the same angle.
So, all right. So if the plane is at the subplanar point is the same as the subsolar point, is that what you're saying? Okay. So it's between the tropics, right? So if let's say it's on the equinox, if the plane is directly below the sun, then it's on the above the equator, right?
All right, yeah. So I get get where you're going. So let's just say the sun or whatever we're measuring to is 90, and the plane is at 89. The plane is slightly closer to you. I get what you're getting at there, but like you're saying, the measurement's not going to be that much further off. You're still, the plane is closer. You're still observing the same angle up. The plane is sitting right in front of the moon.
But if
You
they're
get
at
what I'm
different
saying?
angles, if they're at different
So
angles,
you're
they're not right in
telling
front of the
me
moon.
you can measure the distance with angles, is what
Yeah,
you're telling me.
absolutely, and that's a fundamental, easy thing.
And how do you notate? So, and
here.
that's the
That's
only way
how.
you can measure anything is at 90 degrees.
Nope, but it's an easy way.
It has to be at 90 degrees.
No, it's but
it's
that's
easy
an
way.
easy way.
So
Yeah.
we've already established, because it could be at 89. I got you.
Yeah.
So let's get off of this topic because I feel like we're spinning wheels. Let's talk about the crepuscular rays on Mount Rainier photo.
Why do you want to change it? I mean, we were just about to get to the good part.
Well, because I got 35%. And I'm trying to at least get to talk about the crepuscular rays before it dies.
All right. Well, so I'll just give you the good
we
part.
haven't talked about the photo yet.
All right, I'll give you the good part here. This particular calculation you can do at 2 latitudes on the same day, and you get a different height for the sun. Doesn't work for flat Earth. All right, well, let's see.
What's the difference in those heights?
It varies. It varies based on the latitude. Doesn't make any sense for flat Earth. So, all right, let's see. Let's see your crepuscular rays.
All right, so we're still on angles and lights technically, but Globers claim that this picture is showing the sun below the horizon.
Yes.
Right, casting an upward shadow.
Yes.
Okay. So then why do we observe the hot spot behind the mountain?
That would be the sun shining up on the clouds.
So the sun is shining up on the clouds, not the mountain then.
The sun can simultaneously shine on 2 things.
But it can't shine on a mountain in the distance if the sun is already below the horizon.
Clearly, it's not quite below the horizon for the mountain.
Okay, well, there was just a couple of Globers had made videos saying, the sun has to be below the horizon.
Let's do this.
And it absolutely doesn't.
Here's your hypothesized flat Earth. I'll draw the mountain here. I'll draw the clouds. And I'll draw the observer. Okay? All right. Right there. See that? Now, where for flat Earth should I put the sun?
Above the cloud.
Above the cloud.
Above the cloud to the left side of the paper.
Like there?
Left side. Well, is that your left side or is that your right? The one you were just pointing
That's the left side. All right. So, and I already measured it 3,000 miles above. So it's going to be out of scale, drastically out of scale because clouds are 10 miles high.
All right. So I was actually saying put the sun closer to the other side is where I wanted it. I couldn't tell which was your left or your right. I'm sorry. So yeah, put the sun on the other side.
All right. So I'll
put it over there above the clouds.
Sun 1, sun 2. All right.
Now, are you going to get a straight edge out and draw me a good straight line for this example?
I have a straight
My
edge.
man. You made sure the cloud was far enough back in the way, huh?
I didn't know where you're going to want to put the sun. But all right, let's see.
So I'm going to tell you, I already see where you're going. How is the sun creating the shadow upwards? Reflection.
There you go. All right, how's that happen?
So, because it bounces off the ground and it'll get trapped in between the ground and the cloud layer.
All right, and so west of
in
that
some
mountain,
instances, I'm not saying every instance. In some instances.
West of Mount Rainier, what's the ground look like west of Mount Rainier?
West? Oh, you really want to know? I've done this experiment in case you didn't know. There's a lake called Bumping Lake. It's about a 3-mile long lake.
A 3-mile long lake. Okay.
It's actually closer to 4, but we'll just round down for.
Okay. And it is always reflecting up, or is it? Where is it?
No.
Let's look where it is.
I didn't say. See, I'm not saying that the lake has to be the reflective source.
Well, then why did you bring up the lake?
Can be the reflective source. Well, you brought up the lake actually. I said it's reflective.
I said
didn't say the lake.
I didn't say the lake. I said what's west.
You said what?
You
what's
said lake.
The ground looked like, and I said no. I brought up the lake because you asked.
I didn't
The
ask
lake
about the lake.
is what I first assumed. So
Okay.
when I first assumed how this could be done in a you asked me what was west of the lake. I mean, what was west of the mountain? I said a lake. Yeah, I was assuming that what was you were talking about. But so I had done that experiment with the lake, trying to recreate the shadow, and you can reflect light off of a water source and get a crepuscular shadow to bounce off of a mountaintop
Crepuscular.
with a lake. But you can also do this without one. You can do it just bare on bare grass if you have to.
Yeah, and
With
get a nice
the sun above the clouds.
crisp shadow like that.
Crisp.
With the sun above the clouds. Now, of course,
Very
in your
crisp. Let me see if I can
move to the side. The
before
picture
my
behind
battery
you.
dies. I'm gonna try to pull it up.
The picture behind you shows the sun is set, but the sun is set
Above the
behind
cloud.
you.
It's above the horizon. This is above the horizon. If you
all
look closely, there's a cloud deck. There's a fog deck right here beyond the trees. And then just beyond that is your mountain. And then further beyond that is your bright light in the sky, which you're saying is a hot spot from the sun being under the horizon, pointing up onto that cloud.
Exactly.
So you're still saying, the way you're saying is backing up exactly what I just said would happen on the flat earth, because your lights get trapped in between the cloud deck and the fog deck and bounce around till they make it to the mountain.
I tell you, fog is not
Do they
very good
not?
at reflecting light. It scatters it pretty well.
Water is very, very, very good at reflecting light or trapping it too. That was another thing I said. The light gets trapped in between the decks, does it not?
No, it doesn't.
If a light gets trapped between two sources, a cloud deck that it can't penetrate on the top or the bottom, it's going to stay focused in the middle. Is
clouds and fog are very bad at reflecting light. They're good at scattering light. Scattering
light. But you get the orange effect from the scattering is what I'm saying. All this is just trapped light. This is not below the horizon. You see the sun right there. You're not looking at it, you're laughing, but your sun is right there behind the mountain, buddy. Your sun is right there. You're laughing because you know the sun is right there.
That's not the sun.
You see it?
That's the sun shining on the bottom of the clouds there.
Oh, okay. So the sun is below the horizon.
That's right.
Shining up on the cloud.
Right.
So then, how does the light make it? How is it making it there and casting your shadow up?
That's a great question.
Can you recreate that on an experiment? On
a sphere? Yeah, that's not hard to do.
On your sphere. Yeah,
that's not hard to do. But
I would love to see it because I haven't seen one glober do it yet. If you do have time, I would to show us a crepuscular shadow bouncing off a mountain off a spear like that with the light source below the horizon.
A spear.
Your globe, your blue marble is closer to a sphere than a pear than a whatever Neil wants to call it. But
it's not a spear.
I'm knocking your model. Your model. What is it? An oblate spheroid?
No, you keep saying. But let me.
Is it an oblate spheroid?
Oh, hold on a second here.
Are you still trying to get me to explain how my model would work? I'm trying to show you. I'm just slow.
Here's the word.
To it.
Here's the word you're saying.
You're mistaking my country accent for
H right there. You got to put an H in there.
I know what a spear is. I know what a spear is. Indians use spears. It's sphere. I know, yeah. I have a speech impediment. Thanks for picking on it, bud.
All right, I'm sorry, man. Just having fun. Yeah. Oh, look at that. Freddy Krueger's in your chat.
I do get dry mouth a lot when I'm talking. Let me just find my video. I'm never, had to go back and forth finding videos and stuff like that. But let me see if I can find it real quick. So, where's it at?
I see Freddy Krueger in your chat. How is he typing with those fingernails things? That's tough. It looks like Freddy got confused when I did when I drew the flat Earth map, the flat Earth hypothesis test here. He got a little confused about this. So Freddy, find a tutor that's like that does math tutoring somewhere in your area. You find a good one. Pay the good money for it, Freddie, and And start around 3rd grade, maybe. And then once you get up like to 11th grade, then come on back. All right.
I'm trying. I'm going as fast as I can, buddy. For some reason, my TikTok doesn't look the same as it does. Here we go. It's just slow lagging that damn Apple phone, man. Thing don't want to work worth of nothing.
I don't know. It could be a pebcac.
I wouldn't own an Apple phone.
Do you think it's a pebcac?
What is that?
Yeah, it's a common error. Could be.
I got you. Yeah, it could be.
Could be. Oh yeah, we got Mary Ann in the night owl says that Freddy Krueger uses his knuckles like those gals with the 10-inch long fingernails do. Oh yeah, type with your knuckles. When they have those long fingernails, oh, gross. Ladies, nobody likes that. Well, I don't. Maybe people do. All right.
So I've never had so many technical difficulties in one night in my life.
It's because I'm a wizard.
I was looking for.
It's because I'm a wizard.
Yeah, I see.
You go to mctoon.net/wizardry. You'll see. You'll understand it. Yeah, Mute Donkey is confirming it's a pebcac. All right, well, let's see. Eddie Reese says the sun is encased in the dome, so it's like a double pane window and the sun moves around in between.
That's what I think.
It's an interesting idea.
Stuck in a track in there.
In a track. All right.
Well, the book of Enoch describes it as like wheels in the sky.
Yeah,
it's on a
but the book of
wheel.
But the Book of Enoch is just kind of a low quality or mid-range fantasy background. I prefer the Silmarillion to Enoch. It's a little better. It's more coherent.
All right. So I cannot find it. I will have to. I know it's on my phone, but I can't get it off the live and pull it up. But I'll just have to tag you in it and just let you look at that. I did actual experimentation, showing that with a light source above the cloud deck and the mountain deck, you can most certainly create crepuscular shadows.
All right. So somebody was asking about your picture. Jolene says, found your picture on /r/Wall Street Bets. And
that's where I got it from.
David
Wall Street Bets.
David Dorinzo. Let's see what he says. 2 dudes with southern drawls back to back, Mike. It's been a long summer down there. Their brains are cooked. Leave these poor people alone.
Oh, yeah. Here we go. I don't know why it was. Let me see if I can flip my camera around. It was there. It just, when I went to go play it, for some reason, it didn't play the whole video through. And I thought for some reason it wasn't there. I'm telling you, everything's wacky on me tonight. It's your fault, McToon.
Wizardry. It's all wizardry.
All right. Now let me see if I can figure how to flip the camera. Gee, such a rookie. All right, did it flip?
Nope. Well, I don't know. Maybe it's still showing the background there.
Maybe I need to take the background off.
Freddy Krueger says that I'm avoiding him. Freddy, I'm happy to debate you live. If you want to face me live because it sounds like he's got some batteries that are about to go away, you can send me an email, Freddy Krueger, mctoon@mctoon.net, and I'll send you a Zoom link, and you can come on here live when DrainoPitt1 is done.
So,
all right.
This still picture here, for some reason, since I can't flip my camera around and show you, this picture is from, all right, I took a 5-gallon bucket, like a piece of square really hard cardboard, not like a cardboard box, but like something that would come under, you know, something kind of, it would be kind of sturdy. And I broke it in half and I leaned it over the side of the 5-gallon bucket. I took a piece of packing foam, white packing foam, like a sheet packing foam, pizza box, and I stapled the packing foam to the pizza box. So what you're looking at there is the crepuscular shadow that I created off that 5-gallon bucket. And the sun, it was approximately 6 to 7 o'clock when this happened. So the sun was well above that.
So
that
significantly
source.
Above the horizon is the sun.
Very well above.
So
Very
definitely
well above.
not analogous there. And what was this? What was it reflecting off of?
The
ground.
What was the green grass?
That's a reflection off of the green grass.
The ground was reflecting the light. I mean, you have ambient light because it was daytime, was it not?
Yeah.
It was midday. I mean, you know, not midday, but the sun was up well above the horizon.
Yeah. So not very analogous.
If you go back to your drawing bring back up your flat Earth drawing where you had your cloud and we put the sun up.
Yeah.
Okay.
But in your picture, we can see that the sun
now
isn't
my
up here.
Experiment is exactly like, huh?
We can see in your
picture.
What? We can see in your picture that the sun isn't way up here. The sun was not even visible.
On where? On just my picture?
On your picture, yeah, the sun wasn't even visible.
Right, because all right, so you have to take it on faith. I have the video. You can go look. It's on my page. You can see I show the sun well above the horizon. I look up at it. It's a clear blue sky. You can definitively see where it is. And then
I'm not doubting.
Sit down next to the bucket.
Yeah,
right.
I'm not doubting that the sun in your demonstration was significantly high. What I'm saying is that in the picture of Mount Rainier, the sun is not significantly high. It's already set.
But we were both just observing, all right? And so we're both making assumptions. Your assumption is that it's not the sun in the Mount Rainier photo when we see the hot spot. Now, the picture was not taken with a solar filter on, so we cannot know definitively if that was the sun or not. We can only assume as a glober that it went below the horizon, as a flat earther that it's still there. And my demonstration is true.
Yeah, of
because
course.
My demonstration is exactly what you have right there on your paper in your hand. The sun above the cloud and mountain on a flat earth. And my yard is flat, bro. And it's creating an upward shadow right there on my pizza box.
That's off of grass.
Off of grass, buddy.
Okay. And do we see the grass in your video?
If it was, yes, you can see. I'll show the grass and everything. Okay. Like I said, when we get off the live, just go check it out. I'll tag you in it. It's actually the very first pinned video on my page.
Okay.
So it'd be the top left pinned video. It's got Globe Man's face on it. You know Tyler Globe Man?
I know Globe Man, yeah.
Yeah. His face is on the front of the tag, so.
We've got Globey McGlobe faces in my chat right now. My YouTube chat.
Oh yeah, he's
good.
He's probably waiting. He's probably screen recording so that he can.
He makes you guys cry all the time. He's good at that.
Oh no! We just keep him honest.
Now here's the problem. Let me cover this little bit of a problem here. If the sun is high like this, like you claim it is, right? And like I measured. If the Earth were flat, my measurements say that the sun has to be 3,000 some feet high. Well, if the sun is 3,000 or miles, 3,000, if the sun is like 3,000 miles high, which of course is what Samuel Rowbotham says, that's what Eric Dubay says. Many flat earthers go with the 3,000 mile high claim. Well, if that's the claim, then the picture that you showed, the sun could never be that low. Because we can do this, we can set up the same triangle. We can set up the same triangle. Hold on, I'll show you.
Like this picture right here?
This triangle. See that triangle?
The sun could never be that low and create an upward shadow?
the sun could never be as low in your Mount Rainier picture if it were 3,000 miles high, right? This here, we can get the angle. If we know this distance, and if we know this distance, we can know the angle right here. And this angle, if the sun is 3,000 miles high, can never be less than 9.5 degrees anywhere on land other than Antarctica.
Okay. Now let me take you on the same route I took Globy McGlobeface on with this. Go back to your flat picture with the clouds. We're gonna do one more drawing.
All right.
All right. Now put a stick man under 90 degrees directly under your sun. Put one stick man over there by your right side sun. I guess it was.
There's sun 1 and sun 2.
Yeah, sun 2. Put a stick man there. It doesn't matter which.
We're gonna put a stick
just
man
90 degrees directly under the sun.
So he's gonna be between the tropics, because subsolar point is always between the tropics. So there he is. Okay.
Okay, but so you're still thinking in 2D. We're not in 2D. He's just.
Oh, I'm thinking in 3D.
So if we were looking at a side view of the mountain.
Yeah.
Okay. So but we don't have to have that for this little experiment right here. This explanation. All right. So you have the man standing over here under the sun. Now, if you take your sun and move it halfway through the page towards the mountain and keep it on the same plane that you have those two at right now, put you another sun in the middle. So the sun moved during the day closer to the mountain. All right. Now, what happened to the observer angle, the number 2 observer angle? To the sun. What happened with his angle?
Well, the problem is that
observation
this guy is in the tropics.
No. We're still standing beside Mount Rainier right now. Side section of Mount Rainier.
Who is this guy? Or do
So
I need to do another guy?
No.
Do I need to put another guy in over?
Put under
over
the second. Okay. Do you have a square? You got a speed square?
Yeah.
You know how to make a right angle?
Yeah.
All right, let's put it on that number 2 sun. Draw that 90-degree angle down to your stick man. So he's not standing at the Tropic of Cancer. He's standing beside Mount Rainier, but from so we are the observer looking at your paper, correct?
Yeah.
And you can even put your crepuscular shadow coming off, going up to the clouds or whatever. We are the observer looking at this paper. We're looking at these two guys standing there.
Okay.
The guy on the number 2 sun appears to be 90 degrees, does he not?
Yeah, he's at the subsolar point.
He appears to be directly under.
He's at a subsolar point. Yeah.
Okay, so he would be looking up in a sense, so to speak. So if the sun moved closer to the mountain, that observer angle would what?
This guy's observer angle would decrease.
90.
Yeah, it decrease.
Okay, so that's a flat plane. That's how that works. Welcome. You're welcome. I just explained it for you.
All right, but none of this works yet. We still don't know how those shadows could be cast upwards like that, or how the sun could appear that low.
But you just told me though that the angle decreased, did it not?
Yeah. Everybody other than who's directly under the sun.
Flat plane.
Everybody other than
on a flat plane there,
Listen.
Mr. Stickman. You're standing on it. We're talking about these observers. You're standing on a flat plane, right? The sun above them is on the same level plane. It's not increasing or decreasing altitude. Same plane. So his angle decreased, did it not? You can laugh all you want, but you just admitted that on a flat plane, the angle decreases as the sun moves away from you.
Yes.
Does it not?
Yes, everybody that's not at the subsolar point has less than 90 degrees. Whoop-de-doo.
We're not talking about the subsolar point.
That's basic geometry.
We're talking about the side view from the Mount Rainier picture, man.
All right. So
get it?
So what's your point there?
So I gave you the point is, if you're standing on one side of Mount Rainier and you're watching the sun go away, whatever, and you're saying that it's going around the curve of the ball. It's no different than if you're standing on a flat plane.
We're testing flat Earth here.
You're standing on it's no different. Okay, it's no different than if you're standing on a flat plane and you have convergence points on your perspective, on your horizon. You're coming to a convergence point, are you not? So at some point, so when that number, okay, we drew the 90 down to the stick man.
Yeah.
When it makes it over to number 1, is his angle even more decreased than it is
no,
at the middle?
it can't get to number 1 because Mount Rainier is not inside the tropics.
We're talking about the stick man's observation to the sun.
Yeah.
Can you draw a line from the stick man with the line above his head?
This guy? Yeah.
Draw a line to the middle sun. Draw a line to the middle
okay.
sun from that stick man.
All right.
And then draw one to the other sun. And let's observe those angles. They do what?
They decrease. Yeah. This is pretty basic geometry.
Yep.
I don't know what the challenge is.
Yep. So at some point on that flat plane that you're standing that stick man's standing on, that flat plane, the further the sun goes away, he's not going to be able to see it at a certain point, is he not?
No,
it's going to go behind the mountain.
The mountain will obstruct it.
It's going to be obscured by the mountain.
But to be clear,
right? If you
this
had
guy
enough paper to draw another 3 or 4 suns, if you had enough paper to draw another 3 or 4 suns, every line you drew would get closer to that mountaintop, would it not?
Yeah, but
And it
I
has
think you're
nothing to
missing
do with a
you're
curve.
missing
With-
you're
it has
missing the
nothing to do with a
triangulation.
curve.
You're missing the triangulation on this one here.
No. We're not talking about the distance to the sun. We're
No,
talking,
I'm talking about triangulation.
perspective.
Yeah. Yes, but and you calculate perspective
You're
with
still trying to measure
triangulation.
the distance. I'm not measuring the distance anymore. I'm showing you how this observation can work on a flat plane.
Okay, but the problem is that you forgot that the sun never goes farther north than the Tropic of Cancer. You know that, right?
What does that have to do with the angle decreasing to the number 2 observer?
Because if the sun is
If
once
he's
over
standing
here,
there watching a sunset,
yeah, if the sun is over here ever,
right?
and this
And,
is
all right, so let's
this
just
is
say
the-
it's
this
noontime
is-
for him right there. It's noontime.
yeah, noon.
It's
So this
noontime
is-
for him right there. Right.
Yeah.
So it's 3 o'clock in, 3 or 4 o'clock, whatever, in the middle. 6 o'clock at the last sun. When it gets 7 or 8 or 9, the sun is still on that same altitude. It hasn't dropped any on the horizon because it has due to your perspective, which is an illusion.
Well, perspective
It's
is
not physically.
It's easy
You're not
to calculate.
physically rolling backwards on a ball.
Just to be
as
clear,
you're watching the sun drop.
Drano, just to be clear, perspective is easy to calculate with triangulation. That's all you do. All of these things I've been doing with triangles, that is calculating perspective. That's how you do it. So you know where something should appear based on its size and its distance from you using triangulation. So
We're not discussing distance. We're discussing
you are.
right now with
these
this,
are getting
with this.
more distant from this
No.
person. From this person's
yeah,
subsolar point. They're
they
getting
are.
more distant.
Exactly.
Yeah. So we are talking distance. The
Right.
distance has increased.
Okay. The distance has nothing to do with the angle that you're observing.
Oh, it absolutely does, because as distance increases,
No.
the angle decreases.
Yeah. Okay,
It's
but
an,
you're
it's
trying
an,
to make it about distance.
yeah, it's an
You're trying to
arctangent
make it about
relationship,
distance, though.
right? You know,
Okay,
arctangent relationship.
So throw
right?
distance out. Throw distance out right now. Stop thinking about distance. You're stuck
Right,
on it.
but then we can't have
The
these
observer,
other
the
spots.
number 2 observer.
Yeah, this guy.
What do you mean? If you had more suns, you're
So you-
your number guy here
you
at the
wanna-
beginning. On these 2 flat planes you have,
Yeah.
that flat altitude on the sun and that flat ground, the sun still sets due to perspective.
As so you're saying
Right.
as the distance increases, that angle goes down. You're saying, right? It gets smaller.
I think we can
the angle
both,
gets smaller. But
we can
but
both
here's
assume yes.
but
that
here's-
when I see a sunrise, the distance comes to me and then goes past me.
Yeah,
yes,
but
I
here's
think we can agree with
here's
that.
the problem, though. This is non-linear. This is an arctangent relationship. It's actually an asymptote. It never gets to 0. This angle here never gets to 0, no matter how far the sun is away for flat Earth. It would never
You
set.
can't prove that. You can't
No, that's
prove
that's
that. You
actually
cannot
just
prove that.
that's actually just
No, because
high school
if you-
geometry.
okay,
I can.
get you-
It's easy
Get you a
to
bigger
do.
piece of paper.
Yeah, you could have a
Get you a bigger
piece of paper
and run
that's
5 more suns.
yeah. You could do 1,000 more suns. This
Right.
angle never will get to 0. Never.
No. It will absolutely get
Whoa.
to zero to the observer.
Excellent. What,
To the
at
observer,
what distance?
listen, to the
At what-
observer, it will absolutely appear because of perspective.
All right, let's
Perspective.
test that. So let's do
It'll
this.
absolutely appear to get to zero due to perspective.
All right. So I
All day
will.
long.
Yep. I'll do this. So what is the actual distance that
Do
it
you
needs
understand
to
how
get?
convergence points work? Convergence.
Absolutely, I do. So all right. So here, I'm drawing a few here. Right. Oh, this is gonna be fun. I like this. This is a good idea. All right. So this angle here is theta. I'll show, right. Usually your default angle. So there it is. There we've got lots of suns increasing their distance, right? And here's your observer. And this angle here is theta, right? You see that angle theta? So now if this is 3,000 miles high, as we've already determined through measurements, right? If this is 3,000 miles high, how far away?
You assumed because you heard some. You assumed because
No.
you heard some flat earther say
I
it.
personally did it
That's what you
myself.
assumed.
I gave you my measurements.
You
3,105
measured our
miles.
sun to 3,000.
Yes.
You measured it for us, and that's the calculation you came up with.
I already went through that. Maybe you didn't convert that short-term memory to long-term memory, but maybe people
I
could
just love that
rewatch
you
the video.
You
Okay.
did the math for us and told us how far the sun away is.
Yeah,
That's-
and if
that's
it's
just
wrong,
magical. That's some wizardry right
if it's
there.
absolutely, that's why I have that page, the wizardry page. Well, if it's wrong, then just give me the correct formula. Nobody's ever corrected me. They've only ever said, I don't know, it doesn't make sense to me. That's all I've ever gotten. I've never gotten anybody to say, oh no, this is the correct way to do it. So Draino, if I've done it wrong, I want to be corrected. Please send me the correct formula for it. But until you do that, I will just use
I'll
high
help
school
you right
geometry.
Now. I'll help you right now.
High school geometry is all that
Take
we
a
need.
fresh
for
piece
this.
of paper. Take a fresh piece of paper.
Okay.
Get you a fresh one. Stick it on the side.
Okay. And what do you want me to draw with it?
Stick it beside that you have right there and keep drawing your dots and keep drawing your lines.
Oh, you want more?
And tell me.
You want more? Going
Yeah,
off.
tell me
Okay.
it's not gonna decrease
It will, but it will never get to
when
zero.
you have a mountain
Theta,
in your way.
theta will never get to zero.
Okay.
Never.
You still assumed the brightness and the size of the sun. You
where
still
in here?
assumed.
Where in this formula did I
assumed-
put the brightness? Where did I use brightness in this formula? To assume it. Where did I
Because
assume
this
it
is
and
what
then
I'm
plug
saying.
it in? Where did I
You're
put it in?
pushing this narrative. You're pushing this
No,
narrative.
you're the
pushing
one
it
that
to
said
right
that
here.
I
So,
made assumptions
okay.
about the brightness. I just want to know where in this formula I put brightness.
Okay, so if you kept drawing dots right there,
Yeah,
and
if
your
we kept
lines
going.
kept decreasing,
Yes.
and you have a mountain in between that and your observer, okay?
Yeah.
So when you get to that point where the sun is behind, it's going to be the light source is not going to be where you can see it anymore.
Yeah,
it's
but
getting out of your
The
viewing
question
distance.
is, when will the sun
understand?
set? The sun sets over the ocean at 0 degrees, according to Flat Earth. How far away does this need
Due
to get?
perspective.
Yeah, this is perspective. This is perspective.
Perspective.
I'm calculating perspective. It's easy to do.
Perspective does what? What does perspective do?
It makes distant objects appear smaller. That's what
And
perspective
converge
does.
to a point, does it not?
No, it doesn't actually converge to
Do
a point.
planes converge on the? Do
doesn't
planes converge when
actually
they fly
converge
over
to a
your
point.
head and go to the other? Oh,
It converges,
why
but it doesn't
actually?
go to a point.
Because it's a curved surface. Huh?
And we can
Right.
easily calculate it
it's an
regardless of the
assumption.
surface. Regardless of the surface, we can easily calculate the position. That's not an assumption. That's basic geometry, high school geometry. If you finished high school successfully, and I'm
So,
assuming you did, you went through
logic
this
tells
stuff.
you.
You went through this stuff.
Logic tells you. Logic
Yes.
tells you
That
if you
this
keep
will
drawing
never get to
dots,
zero.
and you already have established why will it not?
It never will. That's just geometry. This
Because
is
you don't have
this
enough
is an
paper
asymptote.
there, buddy.
This is an
You
asymptote.
don't have enough paper.
Do you not know what an asymptote is?
paper?
Yeah. So
How many
here's the
degrees
problem.
did your angle decrease from
Here's
90?
Here's
How
the
many
problem.
angles did you degrees?
We
on
know.
them lines, just them 4 that you drew,
Yeah.
it decreased what? 45 degrees.
Yeah. It's nonlinear though. It's an arctangent relationship, Drano. Arctangent relationship. It doesn't go down linearly. When you double this distance to here, right? This distance, and then you take that and then go another, it doesn't decrease the same number of degrees. It's a smaller decrease. And then you do it again, it's yet another smaller decrease. And so you get these diminishing returns on the amount that it goes down. This here,
so
this
eventually
angle,
gets to what?
it will never be
zero.
No, it actually never gets to zero.
Oh, it increases. Yeah,
It
it just
never
decreases
gets to zero.
It just stops decreasing, huh?
No,
Right,
it's
my
an
ass, man. You can't prove that.
It's an
You cannot
asymptote.
prove that.
That's
You cannot prove that.
It's actually
You're-
proved.
Some you cannot
it's
prove. If that's what that means, it means you
in
cannot
geometry.
prove it.
It's
You cannot
proven.
prove it. You cannot
You can
prove it.
say that, but all you've done is show that you don't understand the geometry of this. So here's the problem: if the sun is 3,000 miles up, and let's say that the Earth is 30,000 miles, which I don't think that you're going to say that. Let's say it's 300,000 miles. Well, if it's 300,000 miles, this is still a significant number. It never would set. Never could set. Simple
It will set
geometry.
because your perspective.
If
You can't
this
see
is perspective.
forever, McToon. You can't not
Is it
see forever, bro.
Is it perspective or
When you
can't
look
see
out
forever?
into
Which
the
one?
night sky, are you
one?
telling me you're seeing 93 million miles away, millions of miles away?
Well,
That's what you can see, flat, literally.
I
want to
be clear because you're making two separate claims. You're claiming it goes to zero, which it can't, and it's proven. It's
because
geometry.
you don't understand how
Or-
perspective works, obviously.
Actually, I do, and it's easy to calculate perspective. But if
So
I've
if
done
I
it
see a
wrong,
plane,
what's the
if I'm
formula?
sitting right here, right now, and I look
Drano,
out.
if
I look out. All right,
if
a
you
plane comes
understand
over
it
my
better
horizon.
than me, what's the formula for it? You understand it better than me. According
plane
to
flies
you,
over your head.
Drano, according to
The plane
you,
flies over your head.
you
goes
understand
to
it
the
better
opposite
than me.
horizon. What does it do?
what's the
It
formula?
sets, does it not? Is
Dra-
the
no.
plane flying into the ground? Is
No,
the plane flying into the ground,
Drano,
McToon?
you made the claim.
Okay, then. Is
You
it
made
at
the claim.
0 degrees?
Drano,
No.
you made
no,
the claim.
it is not.
Drano.
Because your logic is shot.
Drano,
Because your
listen.
logic is shot.
You claim that you know geometry
McToon,
better
listen,
than me. You know
if a plane
perspective
flies
better
over
than
your
me.
head, does it hit 0 degrees when it gets to out of your perspective?
That's because it goes over the curve of the Earth. But Drano,
no, it does
you
not.
you are claiming
You're busted.
that you know better than
You're
me
busted,
how
man.
perspective works. So show me
I just
what
showed
is
you
the
how I do
formula.
it better than you.
What is the formula?
I just explained it to you. When a plane
How do we
flies over
calculate
into your
this?
horizon, into your view, is the plane coming from 0 degrees? It's coming from under the horizon. Is
Yes,
the plane coming
it's
from
been-
0 degrees?
It's been obstructed
no,
by
it's
the
not
curve
because
of the
it's
Earth.
not touching the ground.
Yeah, it was
It's
obstructed
not,
by the curve of
because
the Earth.
The plane, you don't see the plane. You do not see the plane belly up first. You do not see the belly of the plane first. I've watched
You
plenty of
don't?
planes.
What do you
come
see,
from
the top
distance.
first?
You do not. No,
All right,
you
now-
see the top, the side, and the bottom. You see all
Since-
of it. If it's coming around the curve, I should see the belly of it.
Yeah,
The belly
yeah.
of it first. And then when it goes over the curve, I should see the belly of it
All
go
right,
down. I shouldn't see the top.
All right, Drano, you're running from this because I think that you're scared of it. You've claimed that
No,
you
I'm
know
not running from
perspective
it. You
better
don't
than
understand how perspective
me.
works.
So you've claimed.
You don't-
So
I just
how do we
explained it to you.
calculate? No,
I
you've
just
made
explained
claims.
it to you
How
twice.
do we calculate?
Do you want me to explain it to you again?
I want you to
Do we
calculate
see planes come belly up from
That's
over the
not
horizon?
explaining it.
They're
That's
coming up belly
that's
up
showing
over the
that
horizon.
you don't
All I can
understand
see of a
perspective.
plane
Actually,
is the
Drano,
belly first.
Drano, did
Belly
you actually
first,
pass?
and I never see the top of the plane.
Drano, did you actually pass
So
math
I
class
never
in
see
high
the
school?
top of the plane.
Or did you cheat? Did you cheat to get through math class? Because it's clear that you don't
McToon,
understand this math.
Did you ever take art?
This
Did
is
you ever
way
take
over-
art?
This
Did
isn't
you ever
art.
take art?
This isn't art. This is
Did
this
you ever
is
take
reality.
art?
I did, but this isn't art class.
Perspective, son.
Perspective is
I
you
graduated
can
I graduated
calculate
a master artist. I understand exactly how
With-
perspective works.
yeah,
We
'cause
do
you-
not see the belly of the plane first.
Is it because
Sorry.
you did not eat all of your
Because
crayons?
it's not coming from 0 degrees.
All right.
Because it's coming over a flat plane.
so
it's
then-
already just flying, and you can
so
just
then-
finally see it because it gets close
right,
enough
Drano.
to you.
Drano, expert in
Because
expert
it's a
in
local light source on the
all these
bottom
are-
of a plane.
all these are presumptions. You're just
You
presuming
don't
things.
see the belly of the plane first.
You're just
Sorry.
presuming these things because you start with your
Because it's
pre-selected
not
conclusions.
flying up, over, and around a
Yeah,
curve.
Drano, it's too far away to actually see it very large. That's part of your problem.
How far away is it? How far away is it? You tell me.
I don't. When it's 35,000 feet high, how far is it away when it gets obstructed? It's probably just too small to
You
make
said
out.
it's too far. You said it's too far.
Too far to make out the detail.
How can you tell me?
It's the Rayleigh criterion.
I sit out here every night and day, and I watch planes fly over the horizon.
Yeah, and
I
you
go
get
on the
confused.
app, the flight
you get
radar
confused
tracker
by
app.
simple things. Yeah.
No, I do not get confused. I look at the height elevation that they're traveling. I look at the speed. I look at their destinations, where they're coming from, where they're going to. I live not far from Raleigh, Durham. I don't know if you know where that is. It's a major airport. So I see planes come from all the way in the middle of Virginia when I start seeing them on my horizon.
Okay.
They come up over my head, right? And then they go down south away from me to Raleigh, Durham, and they land. And I can see them all the way until they get about maybe 8,000 to 7,000 feet in the sky. And Raleigh, Durham is about 60 to, I'd say, maybe 70 miles away. I don't know exactly which. It's between 60 and 70 miles from me.
This is amazing science
here. So I'm watching them to there.
Okay.
What do you mean it's amazing science? I just gave you, I can see a plane 60 miles away. We can just round up, round down, whatever. 60 miles away, I can see the plane at least 7,000 feet in the sky.
Okay.
And then it goes away due to light distortion from the airport. I can literally see the light, pollution in the sky at night.
Yeah, okay.
60 miles away on my horizon.
Okay. So
again, planes do not come up over the horizon, belly up, flying.
Yeah, it's
straight up into the sky.
Yeah, it's because the angular size is too small for your eyes to make out.
And planes.
So you say, but they're not. All right. So if you know perspective better than me,
as I said, I sit here and watch it all day.
Yeah. Because your eyes have a certain limit to what they can resolve for detail. When they're too small to resolve the detail, you simply don't see the plane.
Mm-hmm.
Okay, so now if you know, you're running from this.
But
if you know perspective,
if I can see the light,
yeah. All right, you still run from this. You're gonna run from this again. You're gonna run from this again. If you know perspective better than me, then what's the correct formula?
Draw a couple more dots up there, and let's see how much more will decrease.
What's the correct formula?
Since you say it'll come to a point that we never just stop decreasing.
It's called, and if you had successfully completed high school math, you wouldn't recognize this term, an asymptote. But that's why I said I doubt that you actually successfully completed it.
What I'm telling you is, I can sit out here at night and I can see at least 60 miles in each direction. So,
60,
after a sun travels,
why can't you see 500? Why can't you see 500?
Because I have trees and I don't have a completely open.
But
flat,
you said it. But you said it came from over. You said it came from over the horizon. Is it coming from behind trees or is it coming from over the horizon? Which one? Make up your mind.
It's coming from behind the trees, which is right next to the horizon.
Okay,
the trees aren't very tall on my horizon.
All right, so you don't see that. You see it emerge from behind the trees, is what you're saying.
Oh, so you're trying to assert that it's flying straight up when I first don't see it behind the trees, and then when it gets above the trees, it just levels off.
I'm just testing your claim. You said it came from behind the horizon. Then you said you have trees in the way, so you don't see the horizon. So I just want to know which one you see.
My trees are very low from where I'm looking at. My trees are very low on the horizon because they're a good amount of ways, away from me. They're at least close to 1,000 yards away.
All right, so
they do appear very small
All right, so
on the
it does not come.
So it's barely covering a degree or two, maybe.
All right, so you're confirming for me that the plane
And even that close to the horizon, I don't see the light at first anyway. It's only when it gets close enough to where I can see the light start blinking and stuff.
So you see the light, or you see the entire plane? You said you saw the top and the sides and the bottom of the plane.
During the daytime, I see the entire plane. During the night, I use the lights to spot them.
All right, so then why are you talking about nighttime?
Works either way, day or night. I can spot the plane.
But your claim was that you don't see it come belly up first. But because you don't even see the horizon, that can't be true at all. It seems like you're just making stuff up. But here. Let's do this. I'm going to demonstrate for you how an asymptote works. I've drawn this here. You see this? All of these dots across the top are 1 inch apart. They're the same distance.
Mm-hmm.
So according to you, you think that this is a linear relationship because you've never actually done the math on this, but it's not. So I will measure the first one is 90, of course, and we've got right here at 80, and then we've got 69, people. Then we've got 62. It's not linear. Uh-oh. Trouble for you. Trouble. Did you not know this? You didn't, you thought it just went down at the consistent rate. Didn't you? All right. I'm getting there. I'm almost done. Apologies for the looking at the top of my head. Got
No worries.
36. And then we've got 33. And then we've got 30. All right. Here you go. Measured all these. So if you look at this, we've got this gap here, right? These are 1 inch between each of these. This is consistent. This gap here went from 90 to 80, 10 degrees. 10 degree difference. Then it went from 80 to 69. That was 11 degrees. Obviously, my measurements are a little sloppy there. We got 69 to 62. That's 7 degrees. We got 62 to 59. That's 3 degrees. Crap, I was way off. Then we got 59 to 47. 54. That's a 54. Not a 59. 54 to 47. Right? Well, here's what happens. 41 to 36. 36 to 33. There's only a 3 degree difference between these. And this one's about 3 degrees as well. This angle doesn't continuously drop. As you go farther and farther away, the amount of drop
But up
goes
until that
down,
example, it has it
goes
not?
down.
But up until that example, has it not constantly decreased?
It's not constant. It's a
To the
non-constant decrease in angular elevation.
All right, so
Non-constant.
Yeah, okay, I got
That
you.
is-
Yeah,
that is an
I
arc-tangent
I got-
relationship.
I got what I was saying there. Okay, I got you. It's not constant, but is it not decreasing?
It is
The entire
decreasing,
time.
but it never gets to zero.
So if you kept drawing dots, is it not going? How do you know it's never going to get zero?
It's an asymptote. It's a mathematical.
How many dots have you drawn? How many dots have you drawn?
Don't need to do that.
How
It's
many
a
have
mathematical.
How many
proof.
have you go? Because somebody told you it would stop eventually,
No, because
and
that's
you just
that's
went with them?
mathematical.
Or did you?
There is
physically tested it?
There is proof in math. This is proven in math.
Math is a language, is it not?
Yes, this is proven in math.
Can be used to describe things. You can
Yes.
lie in languages, can't you? Right. Okay, so
No,
since we've
this
got
is
that
proven.
established,
No, this
like
is
I
proven
said-
in math. If you think it's wrong, you have the onus to show where it's wrong mathematically. Good luck with that. I think the math is a bit over your head.
Okay, we'll see. I'll definitely ponder on that, and I'll show you how to draw at least 500 dots, and we're gonna at least
So,
try.
Your challenge
I
for
see
flat
you,
Earth.
you constantly keep stopping.
Yeah.
You keep stopping.
Well,
and you
I-
also, all right, so that example too, yeah, I get it's not physically getting to 0 degrees because
Yes.
it's never going below a horizon on the flat Earth. But we have, at ground level, do we not have atmosphere, you have water droplets in there, you have dust, you have everything that all play with your convergence point of your perspective.
No, they don't.
When you're standing, that guy standing there looking at the sun, he cannot see forever because of perspective, can he not? If he's standing on the beach, he's only seeing his dome of view is what? Maybe, according to Globus, it's only 3 miles in each, direction around him.
It depends on
3 miles.
Completely depends on elevation.
Right. So, like I said,
so if they're higher, it's much more than 3 miles. It quickly gets higher than 3 miles.
So you're not, by your example, yes, you're not going to have it. You may not ever have it get to zero. I can agree with that.
Okay.
I haven't tested it myself, but I can see how you could say that it's never going to get. But that example isn't accounting for perspective. It's not accounting to a ground level perspective.
Exactly.
You're not throwing trees in front of the guy.
Trees
are
not
accounting
perspective.
For the light source brightness.
You live near the water. You can get to the ocean.
Do they not?
You can get to the ocean. Yeah. There's no trees. There's no trees. Yeah. You go to the ocean. You look. The sun sets. Yeah. There's no trees in the way. There's just the water that you claim is flat.
Just stand a guy in the mountains. We're standing a guy back in the mountains now. We're in the mountains.
You didn't like that water one, huh?
Crepuscular shadow.
That water one was tough for you.
Well, the water, it doesn't matter. You can still see 3 miles from there. You can see 3 miles from the ground anywhere you can get where you don't have trees right up against you. So yeah, I understand where you're coming from. You can probably say that due to your example there, yes, at a certain height, it's not going to appear to ever drop below horizon, which we don't say it does. We just say it moves from your perspective. It moves out of your
but you never actually do the math on perspective. I showed you how to do the math on perspective. It's not hard. It's solving triangles.
So
that's all it is.
So figure the perspective for one person. How far around? What's their perspective limit? What's their perspective viewing limit if he's standing on the ocean? What's his perspective viewing limit? The farthest he's going to be able to see with the naked eye.
There's no distance that he cannot see, as long as nothing's in the way.
You said earlier that our eyes are not the best at resolution. So if you can't discern what something is, you might as well not be able to see.
You can still see it. You just can't
discern what it is.
Let me explain it, because it's not hard to understand. This is something that eye doctors understand very well. And if you've ever looked at that board that's got the letters on it, they get smaller and smaller. This is exactly that. It's the Rayleigh criterion. You cannot make out detail that's smaller than a certain size. But if it's bigger than a certain size, you can make out the detail. But even if it's smaller than that detail, the light still gets to you. You can still see the light, even though you can't see the detail.
I think we're just going to have to agree to disagree on that. I don't think that can be proven.
You disagree with opticians and optometrists.
Yeah.
Yeah, you're smarter than that.
Because
you're better. You're better at the field
inside doing a test.
You're better at the field of optometry than optometrists.
You're standing inside. When they do that test, you're standing inside. It's not outside.
It's about angular size. It has nothing to do with being inside or outside.
Is that test telling you how far your perspective is?
No, you keep using perspective as if it's a get out of jail free card. It's not.
You can't even tell me how far I'm. If I'm standing on the beach, I'm looking at a boat. It converges with the horizon and goes over where? At what point? At what distance?
How big is the boat and how high are you? It matters.
It doesn't matter. Just do a oil
absolutely matters.
Whatever.
And how high are you?
Do a John boat. Do a John boat.
Obviously, you're very high. You should have studied in school. Easy. We've got Eddie Reese, who is an ophthalmic technician, says I could teach him about vision. The flat earthers constantly pretend that they know more about optics than optometrists and ophthalmic technicians. You don't.
pretending now.
You don't know more
Pretending.
about how the eye works than the people that specialize in how the eye works. You only have watched videos by your Papa Flurfs that told you things that they didn't know anything
can't
about.
Tell me how far my perspective goes.
That doesn't even make sense. That question isn't even a valid question.
Does
All it
your
does,
perspective, when you're looking at a hallway, does your perspective converge?
What you're doing is you're showing that you can't even formulate the question correctly.
Perspective is at play and you're ignoring it. That's what I'm showing.
Perspective makes distant things appear smaller. That's what it does. That's all that perspective does. And they do converge,
because it converges to a point.
Not to a point. They never goes to a point. They get
converge.
Smaller, and eventually it gets small enough.
The horizon is not a point?
No, it's
Is
not.
the horizon not a point?
No, it's not.
So your horizon
It's not a point.
isn't even a point.
I said it 4 or 5 times.
How can you measure to it? How can you measure?
It's not hard to measure to it. It doesn't have to be a point.
You can't measure to
It
something
doesn't have
that's
to
not
be a-
there.
It doesn't
It's
have
not
to.
a point. You can't measure to something that's not a point.
Of course you
It
can.
has to be a point there.
It's
for you
easy to measure.
does it not?
You can measure things that are lines and curves
So
and
you're
edges.
doing wizardry magic. We're just going to measure to something
Why
that's
is-
not even physically
Wha-
tangibly there.
Why is this hard for you to understand?
You just said you couldn't. You just told me you couldn't measure to a. You could measure to a point
down
that wasn't
past. You've skipped down past middle school and gone all the way to not understanding elementary
there.
school.
We're measuring to points
geometry.
that aren't there, McToon. Listen to yourself.
No, it
Listen
doesn't
to yourself. We're
go
measuring to points
a point
that aren't physically
it's
there.
An edge. It's an edge. Can you measure to this
if I'm-
edge? Yes, you can measure to this edge.
If I'm
In
standing
fact,
there on the train tracks, if I'm standing on train tracks looking at a 2-3 mile stretch, what happens to those train tracks appearing? What do
they
they appear
converge.
to do?
They converge.
To a what? To a what?
We say to a point, but it doesn't go to a point because if you got
Oh, that's my point exactly. We're using perspective.
do you had to
We're
interrupt
on
me?
the beach looking at the
Hey,
sun.
Are you scared to hear the actual answer?
Point.
Are you
It
afraid?
converges to a
Are you
point on
afraid of the actual
horizon.
answer? Drano, are you afraid of the actual answer? Is that why you won't let me
ball-
say it? Drano, are you scared? So
You've
you won't
already
even
an-
let
you've
me
already
answer.
answered, brother.
That
You just
must be the
answered.
problem. You are too
answered.
scared of the answer.
It
That's
converges
why
to
you
a
won't let
point.
me
You
say
said
it.
it correct.
Let me explain it to you.
You said it
Are you
correctly.
ready? Are you ready to
Train
explain it,
tracks
or are you
converge to a
still
point.
scared? Are you scared? Are you scared? All right, here it is. Your eyes do not
I'll
have
never be scared.
do
of
not
you,
have the
McToon.
angular resolution to discern that the end of the track there where you think that it goes away and that you don't see anymore. But if you had more angular resolution, what you just need is something that has a larger iris, like a telescope. You could see farther.
So we can bring objects back in with a zoom, huh? Is
If
that
they're-
what you're saying?
If they're too small to see, you can make them larger. Yes. If they're too small to see, you can make them larger. If they've gone
so we can bring things
over,
back into perspective.
you keep using that as if it's a get out of jail free card.
lengthen-
You
and
don't
lengthen- we can
actually
lengthen the
understand.
perspective, can we
You don't
not?
actually understand perspective. You've just heard your Papa Flurf say it 1,000 times.
You're squirming right now, is what I
Oh
understand.
no, I'm laughing at your.
You're
You're just
squirming.
all you've done is parrot your Papa Flurfs. You don't know what perspective actually is, and you just keep saying it because you've heard them say it, and you repeat the same things that they've said because it's been indoctrinated into you, and you've never tested it. You've
just
never
said it.
confirmed.
You just answered it for me, McToom.
No.
It was you that answered that train tracks converge to a point, and then you try to tell
It
me
gets too
my
small
horizon
for you to
due
see.
to perspective doesn't come to a point.
Nothing actually goes to a point. That's the deal.
Well, we know that, but it appears to be. We are arguing that it appears to be, are we not?
And if you get a
Due to
telescope,
perspective, it appears to converge to a point.
that if you get a telescope, that point is now resolvable. So,
What if there's too much fog and haze in the way?
oh, that
and that
absolutely
was why it disappeared in the first place.
then you can't. Correct, you
You're
can't.
going to bring it back into zoom then?
No, you can't. Not if there's
That's
not
my
if there's
point
fog
exactly.
and haze and dust. But things don't get obscured bottom up by fog, haze, and dust. And things don't appear to be lower in the sky due to fog, haze, and dust.
They do to perspective, though, do they not? They do appear to
And-
go bottom up due to
And
perspective.
like we said, we can calculate perspective. It's easy to do. High school math. which you never did.
Yeah. You told me you could calculate to the sun too, but you
Absolutely.
never really finished.
I showed that to you.
No.
You wanted to move on. You begged me to move on from this.
You did it. No, I asked you.
You begged me to move on. You wanted to move on.
Sun on your model. I asked because you
No. We
assumed
started
a
this
flat Earth model from the beginning.
That first
on that.
Absolutely.
I wanted you to do that equation for your sun on your model.
That's not how you do it.
But you took it to the flat Earth model.
That's not how you do it on the globe. We do it a different method.
Right.
But
is that not how they had done it before in the past?
The math would go over your head a little bit.
Answer that you guys changed. You guys moved the goalpost on the distance of the sun. What, 3 or 4 times already?
Good job parroting your Papa Flurf there.
That was the first way they had done it, huh? That was the first way they had done it.
Good job parroting your Papa Flurf. It's all you can do, isn't it? You can't even answer any questions.
You got his name calling, brother. I mean, how many names have I called you or said you're parroting, your faith-based religion?
I'm not name calling.
I haven't done any insulting to you. Yeah, you are. You're Flurf-based, all that, yeah.
What? You're a Flurf, you know it. All right, Mr. QTube, first name Foss, says that he was wondering about your 90-90-90 triangle on Flat Earth that you wanted to do. He said, epic fail.
I said it's not possible. Yeah.
This is what you wanted me to do on Flat Earth.
Angles and end back up.
On a Flat Earth. This is what you wanted me to do on Flat Earth. I asked it several times for clarity, and you said yes.
We were triangulating the sun, were we not?
Yeah, and you wanted to do it by by putting 3 people on a triangle, and each of them are at 90. And you just
triangulating? Is that not going to form a triangle
on a flat plane? How are you going to do that on a flat plane with 3 triangles?
Curved plane, a plate, a pear, a banana.
How on a flat plane? On a flat plane, how are you going to have a triangle with 3 90s?
I never said. See, that's where you're wrong.
I
never
asked
said that you could.
I
said
asked
that your
multiple
globe
times
model
for clarity
says that you can. And if I remember correctly, I didn't say it's possible on a flat Earth.
It's right here.
I said it was on your
90-99 triangle right there. On real flight charts. Real flight charts used by real pilots
10,000
in real airplanes.
10,000 kilometers only? Why
every
can't I
leg.
do one at 10 foot, 10 foot, and 10 foot?
Because the geometry of the spherical trigonometry doesn't work that way.
No.
Each of the legs needs to be a quarter of the circumference. That's how it works. And I would not expect you. I'm not gonna poke at you for that one because
and again, that was something that we could never recreate in reality.
Well, except that flight right
you
there.
You say you do it, but you use flat. You use flat maps.
You use Lambert. I use Lambert conformal conic projections.
Flat maps.
They're Lambert conformal. Maps. Look, not understanding things doesn't actually do it. Yeah.
You put them on a flat desk to line them off, do you not? You lay them out flat,
yeah.
Or do you wrap them around the ball and then
I did. I wrapped them around a sphere.
Answer that one.
I actually really put them on a sphere. And it worked. It was amazing.
Don't you?
So, all right, Mr.
Because you're using a flat piece of paper.
You don't understand the geometry. I wouldn't expect it. I won't mess with you for that because spherical trigonometry is typically not taught in high school. And it's I'm guessing that you didn't go to college and take STEM classes. I'm very specifically saying I did not expect you to know spherical trigonometry. Right? Did you go to college and take STEM classes?
Would that be an assumption?
Yeah, I am. Am I correct on that? If I'm wrong, let me know.
No.
Did you go to college and take STEM classes?
So you have to go to college to understand spherical geometry.
Typically, that's where you would be experience it first. But you could have done it earlier.
Kind of like assuming, isn't it?
Absolutely. I am 100% assuming that you have never taken any classes covering spherical trigonometry. But if I'm wrong, please correct me. Have you?
No, you're right. I haven't. I was just triggering you along there.
And I was being kind by not expecting you to have that be covered.
I know.
All right, Mr. Unite for the Chill Wind says, I'd like a barbecue Cation burger with onion rings and a Coke, please. Have you ever had a barbecue Cation burger with onion rings?
Never.
No? Oh,
I
they're
have had onion rings.
the onion rings. They're a popular thing in Tennessee. I think Tennessee. I think Tennessee. No, Georgia. Yeah, they're popular in Georgia. Onion rings are popular in Georgia. Lance Jess Elias says, will a flat earther ever provide evidence? Will you?
So I think it was you had got on me about, the 8 inches mile per squared was a parabola formula for parabola.
8 inches mile per squared?
Yeah.
Okay.
I know Globers love to harp that that's not the right formula and this, that,
Yes.
and the other, that it's
And-
counting a parabola
And
and all.
I will tell you why it's the wrong formula, and it's different from what all the other guys say. Do you want to know why? Because in that formula you must because you're trying to figure out the bottom up obstruction, and that formula is the wrong formula for the bottom up obstruction, not because it's a parabola, but because it's the wrong formula. The correct formula includes
But what
the
if I
observer
wasn't
height.
using it for bottom up obstruction? What if I was actually just using it to figure out the drop from where my feet are?
The drop from your
Because
feet.
if you're standing on the ball,
Yes, you
if
could
you're standing on the
use
ball,
that.
every point away from your feet drops.
Yep, you could definitely use that for your drop. But I've never seen a flat earther actually test that. I've never seen a flat earther actually go and measure drop. You know how you would measure drop?
There.
How would? What do you? I just hear stuff. I don't see you doing anything. You're trying to do something to the camera. Nobody sees it.
No.
Okay.
Is it flickering or something? No, I wouldn't do anything.
I just heard a lot of noise.
All
right.
Okay.
So
Yeah. Sorry.
if you wanted to measure drop, how would you do it?
Drop from my feet. I would
How would you do it?
Per mile square.
Yeah. So what method would you use to measure that drop?
So I would pick a point in the distance
Okay.
that I could see,
Yep.
and then I would calculate it that way.
Okay. And then then what? Then how would you measure if there is a drop or not?
8 inches per mile square.
Yeah. No, that's just the formula. How would you then go measure that? What instrument would you use to measure that?
So what are we back checking? You're saying me theoretically I should back check it? Is what you're saying?
If you said you wanted to test using 8 inches per mile squared from your feet, how would you do that? And I'm just and all you just keep doing is saying the formula again. I'm asking what would be the methodology for your test?
You figure a point in the distance.
Okay.
You figure that distance.
Yep.
You have your mileage.
Yes,
Okay.
your distance. Yeah, you've said distance in a couple different ways. Yeah. Then what?
If it's 100 miles that you're observing, is that not 8 inches per mile squared, which would be
Yeah. So
100.
you apply the drop
100 times.
Well, it might be a little different than that, but that's fine. You apply the drop formula.
Right, you're squaring.
Yeah. Then what? What would you
And
do
even
to
the 8
measure?
inches is rounded up.
Yeah, that's fine. Unless you have an instrument that's extremely precise, it's not going to matter for this particular observation. But what instrument would you be using?
A triangle.
You'd use a triangle. Like, how are you going to measure, and what are you going to measure with that triangle?
The drop of the ball.
How?
The parabola.
Are you going to hold the triangle up in front of your face and measure something with that triangle? How are you going to do that measurement?
If you're looking out at a lighthouse 100 or just say 30 miles away,
Sure.
that lighthouse is standing perfectly straight, is it not?
Perfectly straight? I don't know, but I don't know how good the builders were of that lighthouse.
It should be a 90.
Maybe they had.
It should be a 90.
Yeah, but let's say it's 90 from there, and they had a reasonably good builder. So what about it then? How are you going to measure from your feet? From your feet, how are you going to measure the drop? What instrument?
It should be 8 inches mile per square.
Yeah. You keep saying the formula, but I'm asking
when
you.
you have a formula. You
Yeah,
have a formula. Why do I need an instrument?
Yeah, you have the formula. Then you test to see if the formula is correct by measuring it in reality. So what instrument would you use to measure to see if it's correct?
What instrument was used to test the distance to the sun to make sure that that was correct?
That's a different topic. Do you want to change topics, or do you want to complete this one?
Yeah. I mean,
What?
yeah. Let's
What
change
instrument?
topics because
What instrument? No, let's.
It goes
I was
along
kidding.
with this.
I was
what
kidding.
Instrument is used to back check the sun distance according to y'all's measurements?
On the globe?
What do y'all use?
Well, one way would be bouncing.
Yeah, on your
bouncing.
model,
Yeah, you
what
can
do
bounce
use
radar.
to back check y'all's math?
Yeah, you can bounce radar off of the sun.
You bounce radar off the sun?
Yes, that's one way.
Okay. And what does that tell you?
It tells you how far away it is because you know how fast light travels or radar travels. They're photons.
What kind of radar do they use to bounce a radar from here on Earth, 93 million miles away?
They used
What
a
kind of
large.
radar is that?
They used a large array in Arizona. They've done it a couple times in the '60s, even. That's one way they did it.
So those radio waves travel all the way to the sun and never hit anything, and then travel all the way back and never hit anything.
Yeah, because generally between us and the sun, there's not a whole lot of stuff. It's pretty much not much there. Yeah. So it's been done. So that's one way to do it. All right. So now back to the 8 inches per mile squared. And like I said, I am with you. It's not wrong because it's a parabola. It's wrong because it doesn't. It's wrong for bottom-up obstruction, which is what everybody wants to test. It's wrong for bottom-up obstruction because that doesn't include the observer height. So let's complete your test. You want to test the drop from your feet to a distant object over water, right? And how are you going to measure that drop?
What do you mean? You have a line from your feet, don't you? You're standing, your feet are 90 degrees parallel to that one point on your ball, is it not?
Yes, they're 90 degrees orthogonal from vertical. Yes.
Mm-hmm.
Okay, and then, so then how are you going to measure that?
How many miles do you have?
Let's say it's 10 miles. How are you going to measure that
Did
drop?
you really want, do you want me to go get a pen and pad and paper and do
No.
it? Is that what you're asking?
No, I want you to tell me the instrument that you're going to use to measure the drop in reality. How are you going to do that? I know the answer.
You're not, because it's not there. You're not going to measure it because it's not there.
Well, you're presuming that. So how would you test to see if your presumption is correct? What instrument would you use to test that? What? How would you see?
Long distance photos that they're like 270 some miles before they are obstructed by anything.
Oh no, but we're talking drop, or are we talking bottom up obstruction? Which one?
We're talking drop, because if you're standing on a ball,
got it.
Every point away from your feet should drop.
Yes.
Should curve away, should it not?
Absolutely.
Okay.
And so how are you measuring that drop?
8 inches per mile squared.
Yeah, that's the formula. How are you measuring to see if that formula matches reality? What instrument?
You plug those numbers into the formula.
Yes, and then that gives you your prediction, right? Classic science, you get your hypothesis, you compute the consequences of that hypothesis. You use the 8 inches per mile squared drop formula, estimate formula, and you say, okay, well, from 1 mile from your feet, the drop should be 8 inches. How do you measure that drop? Mm-hmm. What instrument would you use to see if there is a drop from your feet?
I mean, you could use a line, you could use a square, you can use a many of things. Could you not?
Are you going to have a line that's a mile long?
Are you fishing for one specific answer? Because
are you going to use a ruler that's a mile long and doesn't have any flex in it? That's hard to do.
You can force a 90-degree flat parallel line.
So a 1 mile long ruler that has 0 flex. Is that what you want?
Mm-hmm. No, I'm not saying a 1 mile long ruler.
So
you're wrong.
So the answer is that there are tools, there are instruments that can measure that type of that type of drop. It's called a theodolite.
What are they?
It's an instrument that specifically measures angles. And you know what you would do?
How far does that see?
This is gonna blow your mind. Well, they have a
How
telescope.
far does that theodolite see?
They have a telescope in them, so anything that you can see, you can measure the angle. As long as you can see it, you can measure the angle. So there's no specific distance that it has as a limitation.
So how does the theodolite measure drop?
It's gonna blow your mind. Triangulation. I know. What? You love triangulation. So here's what you do. Because a theodolite can measure from zenith, what you do is, well, you're going to have to put the theodolite down on the ground next to your feet. That's a little bit of a hassle. So let's, instead of having it on the feet, let's put it back up on the tripod, right? Because that'd be silly to use put it on the ground there. Put it on the tripod, and what you do, go to a lake. Go to a nice, calm lake and set up right on the edge of the water there, right? And put something right at the level of the water at the lake. Maybe pound a large nail into the water so that the surface of the head of the nail is right at the same height as the water. Then measure up from there 5 feet, 6 feet, 7 feet, something like that, and then put a target at that height. Right, so you know how far it is. Then you go to the other side. Let's say you're at 5 feet. You go to the other side. You do the same thing, and you bring your theodolite with. Right, you're 5 feet up at the other side, and across there you have a target that's 5 feet up. And then you look through the theodolite and you measure from zenith. The zenith is straight up is 0 degrees for a theodolite. You measure down, and if it's at 90, then it's at the same height, and we have falsified the hypothesis, because we computed the consequences and there should be a drop. If there's more than 90, if you get to 90.1, for example, then you've measured a drop. That's one of the instruments that you could use to measure the drop.
Does the theodolite account for refraction and take that into account?
It does not, but
refraction and mirroring and stuff like that.
Yes,
so
you can yourself.
That measurement, that way of back checking shouldn't be very highly
it's
regarded
actually
as accurate.
It's actually highly accurate. Highly accurate. So what you do is you want to do it
accounting for refraction or mirroring
you
or anything
can
like that. How
listen,
can it be highly
you
accurate?
then when you do the measurement with a theodolite, it doesn't include the refraction, but then you go with yourself after you've done the measurement and you do the refraction analysis as well. So when you're up above the water,
Okay.
you've reduced the.
So let's pause for a second.
Oh, okay.
Let's pause.
I was in the middle of explaining
it. How
yeah.
was refraction? Yeah, I know. So I just don't want to lose the thought on it because I have a very short memory. I'm sorry.
Of course,
but,
yes. We
so
figured
your
that
refraction, how was that figured to be accurate by scientists? How are they?
I was
how do
literally
they know what they hypothesize is happening is what's happening.
I was literally
over
explaining
those
that.
distances.
Yeah. So I'll go back to what I was doing.
Okay.
So you after the fact you do the things that you do because we know that what happens with refraction, it's been measured. So do it on an overcast day because on overcast days the effects of refraction are lessened. Do it up above the water, not right next to the water, because again the effects of refraction are reduced. Then you go and you look at the historical measurements of the effects of refraction in the air, and there's many of them. I have a short list of them on my website at mctoon.net/refraction. Gauss
And
is
again,
one of the
that's
early.
assuming that refraction. That's assuming that refraction is constant over a long distance, is it not?
It absolutely is. Which of course it's not. There are small fluctuations.
It's assuming, yeah.
Yes,
Right.
we know that. But what we do
we
know
agree there.
is we know that in general, refraction causes distant objects to appear slightly higher. It takes a drastic conditions to have anything other than that happen. So if those drastic conditions aren't
you
happening,
mean upwards refraction?
yes, upwards refraction is extremely rare, and you can tell that it's going on because there's typically a large numbers of other hints that are happening at the same time. For example, a super shiny day, really bright sun, things like that. But if it's overcast, that's not happening. We know that because it's been measured in the past to not be what's happening. So you apply that. So the thing is, though, that it causes distant objects to appear slightly higher, not slightly lower. So if something is already lower and refraction causes it to appear slightly higher, well, we know that it's even lower than that, which doesn't help the flat Earth hypothesis. It kind of wrecks that flat Earth hypothesis. Anyway, Gauss is one of the pioneers in the measurements of refraction.
You zeroed it on one side of the light. You zeroed in on one side of the lake, and then you went to the other, and you assumed that the refraction on that side of the lake was the exact same. And
No.
then you measured the angle.
No, you
had
didn't.
a
You
lower
didn't
horizon
assume
on
that it was the
one side
exact
than
same.
the other. So that
Yeah.
was your
Yeah.
that was your proof of curvature.
Yeah, and so you do it from both sides, in fact, and then the refraction analysis that has been done in the past, you apply that. You say, well, we know that in these conditions, this is what refraction does. It makes things appear slightly higher, not much, but slightly higher. So you could apply that, and then the problem, like I said, the problem is when you do the refraction analysis, it does not help the flat Earth hypothesis. It actually hurts it.
Why do you assume that?
It's not an assumption. It's based on historical measurements of the effects of refraction in the air. It causes distant objects to appear slightly higher.
Which is bad for the globe.
No, it's not. Actually, it doesn't help the flat Earth. Because
It's
since
not good
we
for the
know
globe.
since
We see things too far.
yeah, it can cause people that don't like science to get confused about things. Because they will intentionally ignore refraction, but specifically use the times of day and to the conditions where refraction is maximized. It's incredibly deceptive. It's incredibly deceptive. It's incredibly
sunlight reflecting off of water. Refraction. How does that affect? Do y'all guys have a assumption
refraction.
for that?
There's
A
a
hypothesis for that? Do y'all guys have a assumption for that? Like if you're making an observation over where I think there's a pause there.
hold on. There's an echo.
You still there? Like if you're making an observation over where I think there was a little pause there.
Hold on a second.
Still there?
Hold on. There's an echo. I got a phone call, and I think it screwed everything up.
Yeah, that's all.
Hold on a second. I got a phone call, and I think it screwed everything up.
Yeah,
All
it's
right.
all good. That happens. I know you said you
All
had.
right.
I know you
And-
said you had to run. I don't want to keep you all
It was
night.
all right. Hold on. It was my hold on. I can't hear you. It's echoing. It was my kid. He needs me to come pick him up. So I'm gonna have to. We're gonna have to come back, and I don't know why it's looping, but all right. Thank you. I got some super chats to read here, but Drano, it was a good conversation. We'll pick it up some other time. All right. I don't know what happened. That was, I think the phone call messed it up. I need to people. Thank you very much for that. That was pretty fun. He definitely didn't want to learn, but all right. I have to see what my kid says. Okay. All right. He's done soon. I got some super chats to get back to here. Let's see here. I'm going to do the member chats first. I'm going to roll through those quick. I see we've got Triple Croquet is a new member at Newton. Thank you for that. And like I said, I'll be getting back to the other ones after I get through this. Graham Price says, just repeating his Papa Flurf scripts. How sad. Absolutely. We've got LB Stuff Things and More. Things, Stuff and More says, do you like history? Look up the Lewis and Clark method. I have heard of that. I haven't looked at the details on it. Triple Croquet says, is Scott wasted or just a dummy? I'm thinking both. That was not Scott, that was Drainopit1. I don't know his actual name. Maybe it is or is not. So Huge R says, summer, it's winter and it's friggin' freezing. Only 21C today. Bring on summer. 21 C is I don't know, is that hot or cold? All right, that's it for member chats. Back to the rest of them. Alyssum, does this guy have a mental deficiency? Yeah, probably. I mean, he tried. I think he I didn't get as much resistance from him as I do from a lot of people on doing some math. He didn't just say math is fake, right? He didn't say that. So I don't know. Lance Jesse lies for $2 says my son gets why the earth orbits the sun. He's 6. Yeah, sometimes I think, the mind of a flurf, how they got to where they are is interesting. It wasn't a logical way that they got there. So we got, let's see, Alyssum says for 5 Australian, why do even the simplest navigational techniques such as calculating our flight distances require us to account for the globe? They do. And why would a flurf think that a Lambert conformal conic projection map means that the earth is flat? It means that they don't understand navigation and they should not have an opinion on it. You're not smart enough, flurfs. David Dorinzo says for $1.99, bumping lake is 30 miles plus some 9,000 peaks from Rainier, 9,000 K peak. Yeah. I mean, what's west of Rainier, and he didn't want to answer it, is trees. Trees do not reflect light like Mount Rainier shows that it is. Chris Kelling for $5 says, Toon, I can't believe what you did. You did that. What makes it even funnier is that he doesn't even know what it means. ROFL. Oh, what was it that I did? The context of that. That was in the Mount Rainier time. I forget the context of that. But yes, I was messing with him a little bit there. Was it the triangles, the 90-90-90 triangle on a flat plane that he agreed to and then later disagreed? Mute Donkey says lots of trees. Yes, lots of trees. Trees don't reflect light very well, and certainly not to make a crisp shadow on the sun, the bottom of the clouds there. Linux guy for $5.72. You may have a new flurf coming up. Delete laws. He denied the moon landing. Too scared to delete anyone. Yes, I've heard that delete laws is a bit yellow. A bit yellow. Cretan Ball, Fog Deck, Cloud Deck, Mountain Deck. That's the weirdest game of Magic the Gathering ever. Yes. like it gets trapped between the Cloud Deck and the Fog Deck. No. Oh, Pebcac. It was probably Pebcac. That was what Chris Kelly was saying. I can't believe he did that. That he didn't know what he was talking about. I almost asked if it was an ID10T problem. Charlie Castillo II says, I'd be interested in seeing you debate Freddy. You mean Freddy Krueger here? I would love to. I have to go get my son, so I can't tonight. But Freddy Krueger, if that is your real name, send me an email, mctoon@mctoon.net, and I will happily bring you on. So there we go. I don't see one from him. I see a contact from somebody. All right, that's not it. So we've got Stringer News 1 says, I deserve a crepuscular raise. You do. Go give yourself a raise, Stringer News 1. The Sun Express says, lol, he said top left. I do try to work in top left when I can. The Rabbit for $2 says, in what year in school did this one drop out? Yeah, no flurf can solve a triangle. If you can solve a triangle, all of this, its perspective stuff would instantly end if they could solve a triangle. That's all it takes. Lance Jesse Lias for $2 says, physics and math are what allow you to use phones. Yes. None of this communication that we do, none of it would happen if it wasn't for math. None of it. You could not do the fast Fourier transform to send the communication over the wire or over the air. You could not do the ECC correction on the data on the hard drives if it wasn't for math. Right? You could not do the discrete cosine transform for the video and audio that you're looking at right now if it wasn't for math. All of this requires math. And of course, science to make all of these things happen. Alyssum for $5 says, so you can have a right triangle where one angle is 0 degrees. Dumbest thing ever said by a flurf. Yes. Absolutely. He did come back around it. I think he realized you could never get to 0. And he realized that he was not going to win and make himself look smart with that one. So good on that, I guess, for him. Because you cannot, flurfs, you cannot make yourself look smart by not understanding basic things. You don't prove flat Earth by not understanding basic things. You first must understand these things. Of course, that is the essence of flurf, is not understanding basic things. Charlie Castillo, 2. Imagine teaching dollar store Jesus calculus. Yikes. Oh, yes. Eddie Reese for $2 says, another flurf has no sense of scale. Yeah, they don't have a sense of scale. They don't understand math or geometry or physics. Gaming with both hands says for $2, Drano is obviously named after his favorite food. No, DrainoPitt1. Oh, jeez. All right, Eddie Reese says 10th and 11th grade, when he should have learned this math, he was cutting class and smoking in the back alley. Sounds about right. All right, Eddie Reese, yeah, I'm an ophthalmic technician. I could teach about vision. And yeah, flurfs think that they know more about how the eye works than people that know how the eye works. They have to. Chris Kelling for $5 says, Drainy. Is that his drink of choice? You mean Drano? Yeah. Kids, do not drink Drano. I'm telling you. Or don't eat Tide Pods and that little packet of silica that says do not eat. Don't eat it. There's some flurfs that eat it. They're like, don't tell me what to do. Yep. Oh, jeez. Seriously, they do. Let's see. Lance Jesse Elias for $2 says, can we say Dunning-Kruger effect? Way to flurf. It's all that. They get this confidence from watching all these videos. They're like, I can repeat my Papa Flurf really, really good. They don't know anything. None of them do. Timothy Hope says, for $2 Australian, you keep using that word. He did keep using the word perspective.
You keep using that word. I don't think it means what you think it means.
Yep, that's them. String News 1, question for Drano. If you have a triangle with a flat plane and internal angles of 90, 90, 90, how many sides does it have? I don't know. Timothy Hope for $2 Australians says, bring your own math or shh, Drano. Afraid? Yes. He's like, he keeps saying, he keeps claiming that people don't understand perspective, but he can't actually do the work. He just says things. Like that he can see the planes. This was great. The plane coming up from the horizon, top first and sides first, when he has trees in front of the horizon. I think he was lying. Oh, geez. Geistview, I love this. Geistview says, hold on, let me get this. Says, can this sun be brought back to full with zoom? All right, I need to put that on. I'm pulling it up. Hold on a second. I'm bringing it up. Gotta set up the scene. There it is. Yeah, and then Geistview sends this picture here. Can this sun be brought back with zoom? I tell you, Flurfs, no amount of zoom will ever change how much something has been obstructed bottom up. The only thing it can do is make it bigger, but the amount of obstruction is identical. All right. Oh yeah, I will have to do that later. The Mute Donkey, the video that he has of the shadow. I don't think we saw this. I think what he did is he actually has the concrete. I suspect, I don't know, the concrete of his driveway, I think is what is causing the reflection. But thank you for that, Geistview. I anxiously await a flat earther to bring that back with zoom. Eddie Reese for $2 says the crickets are screaming at him because they know. Love that. Abellis with, I think that's a Ukrainian flag there, says for 5 Canadian, I have a 12-inch Skywatcher telescope. Once the moon and stars are over the horizon, I can no longer see them no matter what power I use. The number of times that flat earthers think that they claim that you can bring something back after it's gone over the horizon is amazing. It's amazing. And it's because Dearth says it. Dearth constantly says it. But never once has there been any video or picture, anything where that's brought something back. It's too small to see, yes, but that's not over the horizon. Hessifer, do you not? He kept saying, do you not? But thank you for that, Hessifer, for the $1.99. He's trying to sound fancy. I get it. Stephen York or Stephen York. Why is Stephen, why is S-T-E-P-H-E-N? Why does that PH get a V sound? Sometimes it is. Sometimes it isn't. I don't get it. Anyway, for $7.99 Australian. Size of the brightness grown. What's the relevance? Great metal band name, though. I love that. Yeah. Well, you assumed the size of the sun. Well, where did I put that in my calculation? And the brightness. Where did I put that in the calculation? It was just a straw grasp, is what it is. He didn't have an answer, and he couldn't just admit that it didn't make sense. Timothy Hope for 5 Australian says, is Drano more interested in being special than honest? Integrity knows when to speak and when to learn. I believe in you, my dude. There you go. Special message to Drano. Integrity knows when to speak and when to learn. NANA for $6.66. Hail Santa says, Flat Earth is as fake as the Rubik's Cube I'm supposed to get. Touche. And I really don't have an excuse. I really don't. Naughty tune. You better send it. Timothy Hope for 2 Australian says, high school math teacher here. This hurts my head. Thank you, Timothy Hope, for teaching high school math. These people need it. Obi-Wan for $10 says, thanks for the fun. Same old flurf crap. They never get smarter. F-14's rule. Got a little skirmish between Obi-Wan and Roland my boulder last week, right? They kissed and made up, don't worry. 3 Ron for $2 says, hit the like button, people. Yes, hit it. Just an odd number of times, though. Once or thrice, or what's the number for 5s? I don't know. It only goes up to thrice. You ever think about that? Once, twice, thrice. There's nothing for this one. Nothing for this one. I wish there was. You could say twice. It doesn't work. Fice. Nothing. It doesn't work. It's unsatisfactory. Somebody, we should petition the English language and fix that. Dave Fear for $5 says, if you see the tops of planes, I think there's a problem. Like that Denzel movie Flight. Yes. I hope you don't see the top of a plane as it comes over the horizon. Something's wrong. And the final one here, Humphrey Pushcart for $6.66. Once again, Hail Santa says, listening to Festus makes me weep. I'm getting hammered. Enjoy your hammering. Charlie Castillo says, looks like Dranopit assumed that I lost. Oh, that's cute. Mute Donkey says Penteus. Oh, come on. That doesn't even. It's once, twice, thrice, something Penteus? Maybe. I don't know. Go discuss it in the comments here. The OG Kenji says, I'm now very, very expert. Jay, when you get to 9, it would be knife. As Mike Tyson would say. That. Today, Extra J, that comment won the internet. Tim Mack says, I sent MC2 in a personal message. He sent no link. That's right, Tim Mack. Not tonight. I have to go pick up my kid. He's at work. He's done. He sent me a message a little bit ago saying he's done. And he's done. I need to go get him. So, people, thank you very much. Next week, I have Dion Smo. Be ready. Get your overalls. Get your suspenders on so that your pants don't get knocked off by Dion Smo. Mute Donkey, go ahead. Go run with that one. I won't be saying it. Oh my gosh, I love that one though. That's good. Deanne Smoes next week. I will be September 10th is a full moon. I will be hopefully testing to see if moonlight is indeed cold. Somewhere outside in the Minneapolis St. Paul area. So if you're interested, come to my Discord server and I'll figure out where it is. We'll talk about it. We'll make it happen. I'll do it alone if I need. I don't need validation. I'm okay. I'm okay with myself. So be ready for dance mode. Be ready for the cold moonlight. I'm just fishing. I'm making up time here while I get my outro roll going. So everybody, thank you very much. It's been a great night, and we'll see you next time.